Alrighty, part 3 of our surface area thing, and again just a couple of quick examples. We've seen this before in the class and a couple of the activities. So let's go ahead and look at our first example. What I got is a composite figure, and again composite is two or more things put together. And we very often have to combine formulas, use other things, and there's more than one way to do these. Just because I'm doing it one way doesn't mean you can't do it another. Just prove it, show your work, show your logic, and you should be good to go. But I'm going to continue to focus on the state of Texas EOC formula chart, and we're going to use those. First thing you want to do is identify what you're dealing with. We're identifying with what looks like a cone and a cylinder. Then we come up with our strategy, our plan. Our plan is basically find the lateral surface area of this cone and most of the area of the cylinder. Now see this guy right here? I'm going to go around. When I think composite figures, given no other instructions, I'm going to find the total surface area of the thing I can paint. Imagine getting a paintbrush and painting this thing. I cannot paint this one base of the cone or the top part, if you kind of tipped it up on its right side, of the cylinder. No, it's not going to happen. I'm not going to get the paintbrush inside there. So what I want to do is I'm just going to go ahead and come up with my plan. I'm going to find the lateral surface area of my cone. And I'm going to go down here, pi RL, and I'm going to add it to the kind of the surface area. It's like I'm going to chop part of the formula off of the cylinder. So the surface area of the cylinder, all right, is going to be equal to, and we go down to cylinder. I'm going to take a look at this. But I only have one base. So that 2 is going to go bye-bye. So I'm going to do 2 pi r times h plus pi r squared. All right. So what I have here is the lateral surface area of this cone. I don't need to do the base. And I have the surface area of the cylinder. I don't need to do that base, but I do need to do this one. Plug in. So I'm going to add these together. I could do it all in one fell swoop on this fancy calculator of mine. So I'm going to do pi RL. Well, my R is what? My R is right here. Ding, 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 ding. Okay. So I got A squared plus B squared equals C squared. Because I got to find my lateral, my slant height right here. Here's my lateral height. I got to find it. Plus, I'm going to need this for my radius. Oh, I got my lateral height. It's 10. I need this for my radius. Silly me. Okay. Well, I know it's a triple. It's a 3, 4, 5 triple with a scale factor of 2. But if you want to, you could do 10 squared minus 6 squared is going to equal to b squared. So 36 minus 100 gives you 64. Square root of that is 8. So I know that this radius is 8. You can work it out if you want. Plug in. So I got pi times my 8 times my slant height, which is 10, plus, I'm going to go ahead and continue down here, 2 pi times my r, which is 8, times my height. That gives me my lateral surface area of my cylinder, plus the area of one of the bases, pi 8 squared, which is 64. Okay? I could put this whole thing in the calculator minus the pi's because I want to keep it exact. And RCASI will still give you exact if you wanted to put it in there and make it look at. But I'm going to go 2 times 8 times 12. 2 times 8 times 12. And I'm going to do plus 64 or 8 squared, however you want to write it. Okay? Uh-oh, I didn't quite get that 12 in there. So let's do it again. Well, it's going to be 16 times 12, but we'll go ahead and do that. 2 times 8 times 12. Calculator do exactly what you tell it to, so you always got to think about what you're doing. And see, I'll do 8 squared this time. Boom. 256. Don't forget your pi. So 256 pi. Silly me. I got to add this part into it. I just found my cylinder part. I got to add the cone part in. So let me add that 256. Let me go ahead and do that. 256 plus, and 8 times 10, right? 8 times 10, so 80, plus 80. 80, boom, 336. So my actual complete full answer is 336 pi. And that's what I would put in the calculator to find my approximate, if I so desired. We have a silo, grain silo, or whatever it may be. And folks, people use this all the time. This is huge in the real world. Trucking industry, train industries. Volume is big. Look at your cereal box. There are people that work for Kellogg's who are calculating area versus cost and all that stuff. All right? On the best shape of box and stuff. And that's what we're going to explore when we get into volume and area, surface area, all that. Really cool stuff. Okay. Now, we need some information. What are we dealing with? We're dealing with a sphere, half a sphere, 1/2 a sphere, okay? And we're dealing with a cylinder. So what we want to do is find the surface area of the cylinder, including this base under here, but not this base here. No. And we want to find a sphere, but half a sphere. So we're going to multiply the formula by half. So let's go ahead and write what we know. Well, here's my sphere formula. We're going to cut that in half, so it's going to be 2 pi r squared. So 2 pi r squared, write your plan down, okay, plus my lateral surface area plus 1 base. So here's my cylinder. I'm going to have my lateral surface area plus one of these bases. So it's got 2 pi r h plus just one base. So that's pi r squared. No, they're not. They're round. All right. So we're going to plug in 2 pi r squared. And my r is 6. So 2 pi 36, or I'm just going to go ahead and plug it in for you, 6 squared, plus 2 pi times 6 times 9, so 54, plus pi r squared, which is 36. All right, and we're going to put all this into our fancy calculator. Do a double check, make sure I didn't skip anything. So 2 pi r squared, 2 pi r h plus pi r squared. It's okay to be a little bit paranoid on this stuff. So we got 2 times 6 squared. Let's see how our handy dandy calculator handles this. Times 6 times 9 plus 6 squared. And we get 216. Promise it all works out really well. And 216 what? Pi. And again, if I wanted the approximate, I would have just thrown that in there and be done with it. Alrighty, so unless you have directions otherwise, always look for the exact. And if you're dealing with a more practical, realistic problem, odds are you're going to go to the approximate and round to the nearest tenth, hundredths, or whatever. Alrighty, so that wraps up the surface area examples. It does get more complicated, but we're not going to torture you on that just yet. Alrighty, take care.